Next topic in covalent bonding chapter is coordinate bond or additive bond. Now what is a coordinate bond? It is a type of covalent bond only. So this is also known as coordinate covalent bond. To understand this, I am taking the example of O3 molecule. How O3 molecule forms? By 3 oxygen atoms. So if I am placing 3 oxygen atoms like this, Lewis structures of these are there are 6 electrons in the last shell of each oxygen atom. So I'm drawing the 6 electrons here. Each oxygen has 6 valence electrons. Now start from one side, complete the octet of oxygen atom. These needs 2 electrons, so what they will do? They will share two electrons with each other. And the 2 oxygen atoms are stable like this. But still one more oxygen atom is left to combine with this. So now see, the possibility is of a coordinate bond when one part of molecule is already stable and some other atoms are left to combine with the central atom. Then there is a possibility of this coordinate bond. In coordinate bond also there is sharing of electrons, but it is not the mutual sharing of electrons. For sharing the electrons, they come from one atom only, not from both the atoms. Other atom is just sharing those electrons of the other atom. So like here, the lone pair of electrons are left on this O atom. These lone pair of electrons, it can share with this O atom. Both these electrons, 2 electrons, it can share with this O atom. So like this O will get 2 electrons from this oxygen atom. So these electrons will remain with oxygen and these can be shared with this O atom also. So this is also sharing of electrons, but it is not mutual sharing. Both the atoms are not contributing in the sharing. In this case, one atom only will share the electrons with the other atom. So for sharing, this atom should have lone pair of electrons because these only can be used to form the bond with this O atom, and that kind of bond is known as coordinate covalent bond. Normally a coordinate bond is shown using an arrow going from donor towards the gainer atom. So this is a donor atom and this is acceptor. So this is actually shown like this. This is a coordinate covalent bond. So like this we can distinguish it from the covalent bonds. So both the atoms, they will get stability. Even this O atom will get stability. All 3 O atoms are stable like this because they have got 8 electrons in the last shell. Another example to understand the coordinate bond formation is SO3 molecule formation. If I'll take central atom, here is sulfur. Around sulfur on 3 sides there are oxygen atoms. All these atoms, they have 6 electrons in their last shell, including the sulfur. 6 electrons here. This O also has 6 electrons. This O also has 6 electrons in the last shell. Now start completing their octet from one side. So if I start from this side, both these atoms, they need two electrons. So they are sharing their 2 electrons like this. Like this, a double covalent bond will form between O and this sulfur. Like this O also gets stability. Sulfur also gets stability. But now still 2 oxygen atoms are left to combine with this sulfur. So if already one part of molecule has got stability, some more atoms are still left to combine the central atom, then the possibility is of which bond? That is the coordinate covalent bond. And this atom has lone pair of electrons which it can share with these O atoms. So like this O will also get 8 electrons, this O will also get 8 electrons. So there is a pure double covalent bond here. This is a covalent bond, but this is called a coordinate covalent bond, and its behavior is just like a single covalent bond only. So in this there are 2 coordinate bonds in case of SO3. These are examples of the coordinate covalent bonds. Now I'm taking up the Lewis structures of some molecules. In these structures, somewhere we will get the coordinate bonds also. So after understanding the coordinate covalent bond, now we can complete the structure of any molecule, any type of the compound which will have the covalent bond, and it can have the coordinate covalent bond also. This is a carbon monoxide. Carbon and oxygen. Now we will draw the Lewis structure. Carbon has 4 electrons in its last shell. Oxygen has 6 electrons in its last shell. Now, oxygen needs 2 electrons while carbon requires 4 electrons to get stability. So this O is sharing 2 electrons with carbon, and in this way this oxygen is stable because this has got 8 electrons. But carbon requires 2 more electrons. So the possibility here is that this oxygen can give these electrons, the lone pair of electrons to carbon. It can coordinately share these electrons with this carbon. So as a result of this, actually between the carbon and oxygen, we will have a triple bond, because I told you that this coordinate bond will also behave like a covalent bond only. So actually there is a triple bond. 2 electrons, these lone pair electrons will left on oxygen, and these 2 electrons will left on the carbon. So there are not 2 lone pair electrons, only one is left because one is coordinately shared with the carbon. So this is the structure of the CO, that is the Lewis structure of CO. Second example after the CO is carbon dioxide. In this case, central atom is carbon. Around this we have O atoms. Now the Lewis structures, 6 electrons, even here 6 electrons, and carbon has 4 electrons in its last shell. This O will share 2 electrons with the carbon, and in this way this oxygen is stable. Carbon has got 2 electrons from oxygen. Now this has 6 electrons. But this needs 2 more electrons, and oxygen also requires 2 more electrons. So carbon is sharing the 2 electrons with this oxygen atom. In this way, carbon will also have 8 electrons, and this oxygen will also have how many electrons? 8 electrons. So we have double covalent bond here, not a coordinate bond. So both sides there are double covalent bonds. So the structure is O, double bond C, double bond O, and oxygen here has 4 electrons, and this oxygen also has 4 electrons. That means 2 lone pair of electrons are here on each oxygen atom. So this is the Lewis structure of carbon dioxide. After carbon dioxide, next example, O3 example just now I have covered up, so that I am not writing here. I am taking H2O2. Now in case of H2O2, the skeletal structure here is hydrogens. I told you we will always write on the extreme ends. So in the center there are 2 oxygen atoms, and on extreme ends we have hydrogen atoms. Now the Lewis structure, hydrogen has 1 electron in last shell, while oxygen atoms, they have 6 electrons in the last shell. Now start completing the structure from one side. Hydrogen needs 1 more electron to attain stability. So it will share this 1 electron with this oxygen. In this way this hydrogen is stable. Oxygen requires 1 more electron to have stability. So it can share with the next, this oxygen atom only, it's 1 electron. In this way this O will also have 8 electrons. This O has got 1 electron from this oxygen, but this requires 1 more electron. So it will share its 1 electron with this hydrogen. So O will have 8 electrons now, and this hydrogen has got 2 electrons. All these atoms are stable, and in this way between this hydrogen and oxygen there is a single covalent bond. Between this O and O is also a single covalent bond, and between this O and hydrogen also there is a single covalent bond. And there are 4 electrons left on each O atom, that is 2 lone pair of electrons here. This is a structure for H2O2, that there are pure covalent bonds here. Next example, SO3 already we have covered up, so that I am not writing. I am taking HClO4. This is called perchloric acid. Skeletal structure of this is Cl is a central atom here. Around Cl on 4 sides we will have oxygen atoms, and hydrogen, like I said, it's on the extreme end. So around any oxygen atom we can write this hydrogen. Now the Lewis structure of all these atoms, 1 electron here, O has 6 electrons in last shell, Cl has 7 electrons in its last shell, and these O atoms, they have 6 electrons in the last shell. Now from one side we'll start completing the structure. Hydrogen needs 1 electron, so it will share 1 electron with oxygen atom only. And this O needs 1 more electron, so it will share with Cl. This has got 2 electrons, this has got 8 electron, and Cl had 7, but 1 it has shared with this O, so this has got 1 electron from oxygen. Now in this way Cl is also stable. So this part is already stable, and 3 O atoms are still left to combine with this central Cl atom. Now central Cl atom should have lone pair of electrons to combine with these O atoms by coordinate bonds. This one lone pair is shared with this O atom. This one lone pair shared with this O atom, and this lone pair Cl is sharing with this O atom. In this way, these 3 oxygen atoms also combine with Cl and they also are stable. So here H combines with the O with single bond, combines with Cl with single bond, and these 3 O atom also combining with Cl with single bond, but to show that these are not the pure covalent bond, that these are the coordinate bonds, we can use arrow also to show this thing. Now the electrons in the last shell, O has 4 electrons here, and these O atoms contain 6 electrons. This also has 6 electrons. So this is a Lewis structure of HClO4, that is perchloric acid. Next example is HNO2. This is called nitrous acid. In nitrous acid, the central atom here is of the nitrogen. On two sides of nitrogen, we have oxygen atoms, and on one side of oxygen, we will have hydrogen. This is the skeletal structure of HNO2. Now, Lewis symbols, 6 electrons around oxygen, 5 electrons around nitrogen, and there are 6 electrons in oxygen. Now start completing their structure from one side. Hydrogen needs 1 electron, so it shares with oxygen, it's stable. O needs 1 more electron, shares with nitrogen, this is also stable. Nitrogen had 5 electrons in last shell. 1 it has got from oxygen, so 6. 2 more are required, that it will share with this O atom. So this has got 8 electrons, and O after sharing 2 electrons will also get 8 electrons. So all these are stable. So hydrogen combines with oxygen by single bond, oxygen combines with nitrogen by single bond, and nitrogen combines with oxygen by a double bond. So now this way, lone pair of electrons left on oxygen, nitrogen, and this oxygen atom. This is the Lewis structure of HNO2. Next example after this we can take of the HNO3. Similar to this, but now we have 3 oxygen atoms. So around nitrogen on 3 sides we will have O atoms. Lewis structure, 6 electrons around oxygen, and here we have 6 electrons around this also, and nitrogen 5 electrons are there. So these are the Lewis symbols of these. So from one side we'll start completing. Hydrogen has got 2 electrons. O will share 1 with this also. This has got 8 electrons, stable. Nitrogen 6. Now in this case I have drawn 4 electrons only. 6 electrons are here. O needs 2 electrons, and this nitrogen also requires 2 electrons to get stability. So this has got 8 electrons, this O also has got 8 electrons, but still 1 O atom is left to combine with this nitrogen. So this lone pair of nitrogen, this nitrogen will covalently share with this, coordinately share with this O atom. So in this way, we will have hydrogen combining with oxygen by single bond, with nitrogen by single bond, double bond here, and this side actually is a coordinate bond with this O atom, and electrons left on O lone pair here. Even in this case 4, but this case there are 6 electrons and no lone pair left on the nitrogen, because that only is coordinately shared with this O atom. So this is the Lewis structure of HNO3. So like this we can write the Lewis structure of any molecule or ion we can write. For that we should know the coordinate covalent bonds also. So this topic is complete with this.